And welcome back. Sorry about the delay this morning. YouTube also changed some things in the meanwhile, and so, but here we are now. We are live, and this is the last stream before we take a big break for July. For the very simple reason that I will be traveling quite a lot, and I think I showed this before. Let me just find it. So I showed this before. We have. Let me share the screen. 1, 2, 3. There it is. And so I'll be traveling quite a lot. So actually, well, this has passed. But so Anna and Chen will be here at ASM in Brisbane, and then I'll be in Montreal, and then in San Francisco. And so, if you do happen to be in those areas, do please come and say hi. Otherwise, we will see you. We will see you on stream back in August. So we don't take a break in August here in the Southern Hemisphere because it's the middle of winter, and you can see I'm wearing a sweater. The temperatures are often below 20 nowadays, which is about as cold as it gets down here. All right, so preliminaries out of the way. Sure, I play the intro music. All right, so what did today? Let's see. Sorry, setting up. So what I wanted to do today is just continue where we left off. So this is I'm in the right place on the main branch. Everything is clean, so very nice. And we had. So I'm still struggling a little bit with the. Struggling a little bit with camera, so I got a new camera, new webcam. I didn't like it. I think it's not very good. Actually, so when I went, I could only find either this price range or 10x this price range. So I wanted something a little bit more in the middle. 10x was probably a bit too pricey, and this was probably a bit too cheap. So I ended up getting a camera that's fine for zooming, but maybe not great for this usage here. Anyway, so now I'm back to using my phone. Let's switch to the work in progress branch, okay? And now in this work in progress branch, yes, length by KO. So this is what we had done last week. Just run all of it again. So this code that gets the gene positions from the prodigal outputs. And I'm just gonna quickly post on Twitter actually that we're live. Where is this? Where am I? Prodigal. So we got these prodigal outputs and so we load all of the. Oh yeah. Okay, so we saw this in the recap as well. So here need here to fix this, and then so again recap. So what we did, so outputs. So check M2 for example, E. coli, time and output. So minus S minus R is going to avoid breaking up the lines. And so here the queries are encoded like this with this sigma symbol. So that's before the sigma symbol, that's the genome, and then it's the individual ORF. And then the results are encoded like this with the tilde, and before the tilde is the UNIRF ID, and then after the tilde it's the KO. So we use that information here to make this big, to parse this. This is very simple. And then said we're gonna take 3.000 as the unmutated genome, so wild type, mutated genome with 100 mutations, and mutated genome with 1,000 mutations. get the set of KOs, get the set of positions, and now, so we were seeing before that it's actually a little bit complicated because you might have a gene that's here, right? And then in the mutated, just a little bit off, right? A little bit off. And this means that it ends up being a little bit non-trivial to match all the genes one to one. So we're gonna just look at the low-hanging fruit, namely genes where the KO is given by the by KO. So, and we sometimes let's just count this multi-KO. Just count how often we see multi-KO genes. So this is, I just added this just for us to see. Data. Okay, so actually a little bit more than I expected, 340 out of about 2,700 or 2,800, so a little bit more than 10% are multi-KO. So this means that, or actually it's the other way around, are KOs for which there's more than one gene in the genome, but that just doesn't matter. We are looking for, so we were looking here for, okay, one of these days I'll have to fix this. Actually, I have this fixed on my personal laptop. It's just the work one that's. So if you look at the size of the length of genes, so the length of the genes, there's an imperceptibly small difference between the wild type and the 100, and that's a slightly already perceptible difference between the 100 and the 1K. But if we draw the individual lines, we can see that there are a few big drops. So, for example, this big drop. Right, so that's it. So today, so this is what we had. So today I wanted to maybe clean this up a little bit, first of all, and then keep exploring a bit. So first of all, we looked at the 100. Okay, so I'm just okay, so instead of this, let's do it this way, right? So just this way. Actually, not even. Okay. Okay, this is still correct. This is all correct. This is what I want. What I want, yeah, this sounds about right. No, actually, I don't want to do that. I do want to do this. I'm gonna do the same thing I did before, which is I'm gonna do a bit the same. So okay, so I'm gonna import from simulate.py all the tags, and then then I'm gonna loop over the tags. Right, so here, okay. Okay, yeah, we should, let's rename this actually, so it has slightly, let's rename this, yeah. So that I'm just renaming them so that they start with length by KO, and this way, when they're going to be grouped together. All right, let's look for example this one, Bacillus subtilis. Okay, this is pretty nice. Again, very long arcs there, and then a bit of a drop, big drop. Big drop there. It's a bit hard to see. Oh. There. Okay, the other thing I realized, and actually realized that just now, is that checkm2 so checkm2 has a data. So checkm2, so that right? It has a database of KOs that it uses. So we can just plug into that right now and quickly check. For example, this K000 or K00872. We can check how large these are. I think. Let me just quickly see if we do this. Let me do something real quick. So I'm gonna do some. Yeah, that's fine too. Okay, so here, so this is very hacky, but so what I'm doing here is I'm just running parts of the code. So here, so if I do this, then because read seek is a task generator, then seek is a task. If I do this, then it actually runs the task. It's a bit the same as doing this. These are all kind of equivalent. Oh, actually maybe not. This is what I wanted. And now seek is this string. And so I can do this thing quick. And now let me check M2 is running. And eventually it's gonna run diamond, and when it runs diamond, I'm just gonna, yeah, there it is. Okay, I just wanted to see this. Oh, okay, there's this diamond. Okay, this is not as trivial as I hoped. Let me see, can I get check M2? I have check M2 here somewhere. I'm just seeing if I could get this really quick. Really quick. Real quick. There, oh, there's a Zenodo record. Unfortunately, okay, so this is only the diamond. Sorry, didn't mean to download. Oh, there it is. This. What I want. So maybe that's what I want. So let me just. Yeah, something like this is pretty good. Yeah, I don't know what that is. Let's download that. Oops, this is just download it real quick. Okay, this didn't exist. Yeah, let's. Actually, but slightly different. I forget if it exists okay or exists okay. Okay, this is okay. This is good. It's good. All right. So this is okay. Okay, that was downloaded there. Okay. Alright, so alright, so okay, so this is I'm cleaning up this a bit here. Because maybe we're calling it a day with this, or not a day with. Maybe we're okay, so I'm just cleaning up things a bit here. So this is I think once this is a bit cleaner, like now, I think it's good enough. I will commit this to the main branch. Changes in the simulation. Yeah. Okay, this I don't want. That's the that was just the code I was playing around with to trigger. Okay. So. Okay. Yeah. So I'm gonna plot length by KO for all the genomes. Well, all the genomes analyzed. How do I do this? Okay, so that's the work in progress. Now I'm gonna stash this, switch to main, merge the work in progress. I would like probably even to squash it, but okay, I actually wanted yeah, this is shielding. Okay, all right, let's do this. Let's do it this way. Yeah, I wanted to do the equivalent of a squash merge, which I think is, yeah, this is pretty much it. And now, okay, now here's the thing. Now, just run this. I think it's fast there, yeah. So what I want to do, okay. Okay, so I want to do something like this. Sizes by KO. I'm going to call it AA sizes because these are amino acids. Yeah. Something like this, yes. Okay. All right, let's do. Okay, so this is the number of ARFs. I mean, again, this, I think I've commented on the stream before. I mean, the word gene is so undefined. That's a bit hard to know what it means. But okay, but here we have, for example, there are, so we're going to call them ARF to mean, you know, like as an individual sequence, although in this case it's amino acid, so whatever. But an individual amino acid sequence. And then, so some KOs have hundreds, even thousands of amino acid representatives, and some have 3. So I guess with 3 we won't be able to start much, but you know, for example, this one. Oh no, I'm sorry. So this way. Alright, this is nice. Okay, let's do this. If okay, so this means that for this scale, which is KO0031. We don't know what this is. Do we have a numpy? That's database size. I'm multiplying by 3 because of the oh, okay. This might in the database we have a gene with 117. Okay, what would it be? Okay, let's actually look for it. Could it? Okay, takes a while. What's the matter here? Okay. Okay, this might not be as easy as I was hoping, but let's see. Let's actually go for it. I mean, obviously the right database to use would be the GMGC, which is probably what I'm gonna do next. But this seemed like a low-hanging fruit. Also, this is this sound blood fluke, yes. Schistosoma. I don't actually know what this is, but just schistosoma sounds like something you get when you drink untreated water or swimming in some lake, and it's sounds something out of Romanian horror. Anyway, alright, so we probably should be using the GMGC. It's actually a learning thing. Alright, so we would use the GMGC next time. Because with the GMGC we can also select only the complete ones. So the GMGC has complete and has incomplete genes or ORFs, but we can very easily just select the complete ones. A minute. Yeah, so, okay, so this is the sizes. Oh, it's nice, there's this bimodal distribution. But so if we look for 1, 2, 6, 8, all right, that's exactly the center. And if we look, okay, so this is information. All right, this is not bad. All right, I'm not sure. Okay, I'm not sure. Let me just walk through you guys through this. So what? So this is. So for this KO, 003031, you know, which, you know, might as well just look it up. Isocitrate dehydrogenase, right? So for isocitrate dehydrogenase, if we have a gene or an ORF of size 1268, that's exactly the median size, or 49.9, right? This is, okay, yeah, this is the median size. As but if we have it 1058, even though it's now it's the second percentile, it's a big drop there. Right, this is nice. Okay, this. Alright, let's look at this one. 1, 2, 3. I like this one. 1, 2, 3. Okay, this is on the larger side, and this is on the shorter side, but probably not a lot of information there. All right, let's just. Sorry. Let's do this. Do this. Okay, I think this is probably terrible code, but let's do at least 50. Let's do 100. Why not? Let's just count them. We don't need to count them. Okay, this is Pretty good. Yeah, alright, okay, wow. Huge. Right, obviously here we're only looking at the ones where... But first of all, alright. Is there a difference between these two? Still... Now we've normalized it a bit. Okay. Yep. There it is. Huh. Not really, but this should actually be. So there's a small drop in the. Okay, but 100K is a lot. Okay. Alright, tell you what, we are running out of time, so we are going to stop here for today. But I am not unhappy with how things are turning out. Let me check my notes. Okay. Use the uniref 100 database. Okay, let's do this for all of them by doing this. Okay, Alright, so this is a little bit, still a little bit messy. But why not? No module name SciPy. It's okay. I will install SciPy later, but no module name Seaborn. Okay. Let's install it. And while we install it, let's add it to the notes. Start up. We did not install Seaborn. Install Seaborn. So I should have installed SciPy since we're at it. Oh, it's actually Seaborn installs SciPy, which I'm not sure is the best thing ever, but alright. And okay, so I think well, this should take a little bit of time to run, but it should eventually return what we want. Yeah, there it is. Okay. Now this is interesting because now we see a huge drop with the 1K. Questions whether the partly because this is how we're selecting things, not just because it'd be interesting to we're only plotting the ones where there's a difference between the wild type and the 1K, so this is normal, but it's also normal that, so this is the distribution is, see, it's actually, so this, yeah, it's in, yeah, so so we should really be using the GMGC here. The problem is if we use the GMGC for annotation, for getting the KO size, maybe we should have used the GMGC for annotation. But maybe that's fine. By the way, I'm just gonna link this to the GMGC website. GMGC. Also, I've always said that one of my goals with these streams is also that we dog food our own tools and databases, and GMGC is one of them. So I'm also very happy. We will be playing around with it, and if there are things that are wrong and or confusing in the documentation about GMGC, I will use this as also as an opportunity to fix that. Okay, so. Let me think a bit. All right, so what I want to do is I want to add the notes. Notes on installation. Seaborn. Seaborn. Okay, so this is in the main branch. Again, I'm gonna switch to the open. Yep, okay, so now I merge the main branch here, and I'm gonna add this. Okay, so as before, I don't think this code is great. It's a little bit messy. So I'm gonna put this in, the work in progress. So so this project has several goals. One of them is to demonstrate how I work and how I would normally be doing things. And one of the ways I would be normally doing things is I would be working on this for a little bit longer before committing. I often, my projects are a little bit dirty, in the sense that there's a lot of changes that are not committed to Git, and actually, to be honest, I think that's one of the advantages of Git, is that it lets you do that, and then if you don't like it, you throw it away, and you can do this type of thing without too much thinking, because if, oh yeah, this is not good, you throw it away, rather than always be worried about, oh, is this good enough? Is this and then eventually you do have to go through that, and sort of, but Git also lets you do it and check your changes. So as usual, everything's on GitHub. subscribe to the channel, please. Join us on Discord, and I just showing this again one last time. We will be traveling a lot during the month of July, so there's no stream then. But do come say hi if we happen to be in the same city. Do come to just say hi. Do come, and we can talk about the stream. We can talk about science. We can talk about whatever. I'll have a couple of talks as well, both here at ASM in Brisbane, in Canada, and in San Francisco. So maybe that will be interesting for some of you. But in the meanwhile, so the stream is going on break for July. So if some of you in the Northern Hemisphere, if you're having also a holiday, have a good holiday. And I will see you all in August. So see you then. And see you. I'll be posting a recap shortly, also posting on the mailing list, and I will see you soon.